Okay, now we are going to check slightly different type of factoring, right? Slightly different type of factoring. So let's see. We're gonna try to factor polynomial. Second degree polynomial. Second degree polynomial. What do they mean by second degree polynomial? Second degree polynomial, especially in this form, x squared plus bx plus c form. So we're going to talk about a secondary degree polynomial factoring for second degree polynomial that looks like this. Well, what do they mean by looks like this? The first term right here has to be just x squared. Second term, this b is just a real number, any number. And c also any number. They use real number, but just simply means any number, right? So we are going to deal with a polynomial that looks like this. We say this is second degree because we have this 2 there. X squared is the highest exponent, highest power for this polynomial. So second degree, why this is second degree? Because this is 2. If this was 3, then we would have said third degree. If this was 4, we would have said fourth degree polynomial. But in this lecture, we're going to deal with second degree polynomial, especially the first term looks like x squared. Notice that we don't have number there, right? We don't have number there. We're going to deal with the case that we do have number there later on, right? So let's say, basically, let's say x squared plus 7x plus 12. Let's say we have something like this. This is second degree because of these 2. And it's also in this form because the first term is just x squared, no number in here. And we have number there, and we have number there, right? X term and the number term. Okay, whenever that we have a second degree polynomial that looks like this, our format would be like this. Like this, right? So without much calculation or without much analyzing this, you're gonna just talk about this second degree. We're gonna put it in this format. I'm gonna put it in this format. Okay, so once we put it in like this, now what we're going to do, we're going to try to figure out the number that we're going to put it in here and put it in there. When we add these two numbers, it should be same as this number right here, 7. Why is it 7? Because we're talking about the number right in front of the x, the b in this case, right? A b in this format. And when we multiply these two numbers that we're looking for, it should be this number. Notice that I include the sign as well, right? In our case, it's 12. So I'm trying to look for this two number combination. When I add, it's gotta be 7. When I multiply, it's gotta be 12. That must be what? That must be 3 and 4, right? 3 plus 4, that's definitely 7. 3 times 4, that's definitely 12. So plus 3 plus 4, just like that. And that's the answer. That's what we get, right? That's what we get. All right, so let's try a couple of examples. Let's say factor the following. First one, let's say we have x squared plus 7x plus 10. Okay, remember that I told you this is in that form, right? That x squared plus bx plus c form. And our automatic response would be setting it up like this, and we try to figure out this two number combination. When we add, it's gotta be this middle number, 7. Almost same as the last question. When we multiply though, it's gotta be 10. So let me give a little bit of time to think about it. What would be these two numbers that when I add, it's gotta be 7. When I multiply, it's gotta be 10. What are those two numbers? If you need more time, I guess you can pause this video until you find your answer. Right? So it's gotta be 2 and 5, right? Multiply 10, add 7. Well, that's our answer, plus 2 plus 5. I mean, if you want to check whether you got this one correct or not, then you can always multiply this back in here. See if you can restore this original expression. If you can restore this original polynomial, then your factoring is correct. Why? In this case, it is correct. All right, so let's try slightly different. Almost the same, but slightly different. So this time we have x squared minus 6x plus 8. All right, it's almost the same. Still, we don't have number there, so our automatic response would be put that into that form, right? Without much thinking, then I'll just put it like this. Then I'm trying to figure out this two number combination that I'm going to use. When I add, it's gotta be not just 6, but with the sign, so it'll be negative 6. And when I multiply, it's gotta be positive 8. So I'm looking for this two number. Well, when they say multiply to be 8, positive 8, then I have either plus plus combination or minus minus combination, right? That's how you get a multiplication result as a positive, right? If you multiply these two, then that's going to be positive. If you multiply these two minus, that's going to be also positive as well. When I add these two numbers, it's gotta be negative 6. So I guess two positive case is not going to work. When I add two positive numbers, it's not going to be negative result. So I think I'm looking at two negative number. So when I add these two negative numbers, it's gonna be negative 6. What are those two? Must be negative 2 and negative 4. right? When you multiply these two, it becomes a2 as well. So that's our two numbers. So we're going to put -2 and -4, just like that. And that's it. That's our answer. Okay, so let's try just one more. X squared minus x minus 12. Now you can pause this video and you can try this on your own, and you can check the answer with me. So as I told you, this is going to be in this form. Add -1 multiply -12. So multiplying result is negative. What does that mean? That means I'm looking at one positive number and one negative number, right? That's the only way that I can get the negative result when I'm multiplying. If they are both negative, that's going to be positive. If they are both positive, of course, that's going to be positive as well. So I'm looking for this one negative, one positive number. Okay. So this added to be -1. So -4 and 3. How about that? Right? Added to be -1, multiplied to be -4. So -4 plus 3. That's it. Right? Okay. Next topic that I like to discuss is technique called factoring by grouping. Factor by grouping. Factor by grouping. So, you know, when we have let's say x squared plus 4 times x plus x squared plus 4 times 5. Let's say we have to factor this. Instead of multiplying this in and expand it and try to simplify it again, we recognize that we have this x plus 4 there, x squared plus 4 there, and x plus 4 there too. So we have this and this in common between this and this. So why don't we factor x squared plus 4 like this? Remember, when you factor, you gotta put the parentheses. Because we're factoring this one out, what's left behind from first term is just x. Because we are factoring this one out, what's left behind would be 5 plus 5. Why is it plus? Because that's a plus right there, right? So that plus makes this as a plus. And that's the result. That's one of the basic, I guess, concept or technique that we need to know when we do factoring by grouping. Factoring by grouping. So let me give another example. Let's say we have x squared, well, x to the cube, not square, sorry, x to the cube minus 4x squared plus 2x minus 8. Let's say we have to factor this. Now, our first response should be trying to identify any common factor between all four. And I guess we don't really have any common factor between all four. Then what we can do is try to group this first two together and group this second two together and see if we have common factor between these two and common factor between these two. All right, and we do have common factor between these two, which is what? Which is x squared, right? So when we factor x squared from here, x is left behind. When we factor out x squared from the second term, -4 would be left behind. All right, what about these two? I guess our common factor would be 2 there. So when I factor out the 2, x would be left behind. And if I factor out the 2 from 8, looking at the 8 as 2 times 4, so 4 is left behind. All right. Now, see these common terms, x minus 4. Since we have those two common terms, let's factor with this common x minus 4 and open parentheses. Now what's left behind is x squared. So x squared. And what's left behind from here is plus 2. Plus 2. Just like that. So that's our final answer. That's our final answer. And this technique is what's called factor by grouping. And I guess you might ask, oh, how do I know that I'm supposed to use this factor by grouping? You know, factoring is so tricky. Well, let me give you a hint or tip. If you see these 4 terms, then it's highly likely that you have to use factor by grouping. Highly likely that you have to use factor by grouping, right? If you have 4 terms, highly likely that you are going to use factor by grouping, especially when you do not have a common factor between all 4, right? So let's do one more example. Factor. Let's see. Let's try to factor 2x squared minus 4x plus 3x minus 6. Okay. Now, I mean, what might ask, why don't we combine these two? You know, these are the like terms, and definitely you can combine these two. But for the sake of explaining factoring by grouping, let's not combine these two. Let's leave it as it is. So we're gonna group these two together, try to identify any common factor. So I see that 2x is common between these two, right? And I hope that you should be that you can identify this common factor between these two. If not, go back to those previous chapters, the basics, and do a lot of exercise in there. Okay, so once we factor out the 2x and x is left behind, if we factor out the 2x, what's left behind from here? 2, right? You can definitely recheck it by multiplying it back. See if you restore this and this. And we did. We did it correctly, right? Once you multiply that, that becomes this, becomes this. Now what else can we factor from these two? Well, we can factor 3 out. It's going to be x minus 2. It's like that. All right. Now we have this and this in common, right? So let's factor this. Once we factor out, what's left behind is this 2x plus or minus. Well, since that's plus, this is going to be plus, and 3 is left behind. And that's going to be our final answer.